Imagine looking up at the sun, a bright warm circle in the sky, the source of all life on Earth. For millennia, we saw it as a distant, unwavering beacon, but now, we can see its surface in astonishing detail. Thanks to revolutionary new images, the sun is no longer a smooth ball of light but a seething, dynamic landscape. These images are a quantum leap, like seeing a human face clearly for the first time after only ever seeing a blurry dot. We're now able to see features as small as a city, on a star 93 million miles away. The light from the sun takes about 8 minutes to reach us, yet we can now study its surface with incredible precision. This is a testament to human ingenuity and our relentless curiosity. The sun is our star, the center of our solar system, a giant ball of hot gas, mostly hydrogen and helium. Deep inside, nuclear fusion releases immense energy, which travels outward and eventually shines as the light and heat we depend on. Without this energy, Earth would be a frozen, lifeless rock. For centuries, the sun's details were hidden by its brilliance and distance. Telescopes peeled back layers of mystery, but today's images, especially from the Daniel K. Inouye Solar Telescope, are breathtaking. We're witnessing the sun's raw power and delicate structures in motion, a celestial ballet of unimaginable scale. These new views are changing everything we thought we knew about our star. The sun's surface is now revealed as a place of constant activity and transformation. Each new image brings us closer to understanding the forces that shape our solar system. The sun is not just a source of light, it's a dynamic, living star. Our journey to understand it has only just begun, and with every new discovery, we see our place in the universe a little more clearly. What do these new images show us? The sun's surface is anything but calm. Imagine a pot of boiling water, bubbles rising, churning, and sinking. The sun's photosphere looks like that, but on a colossal scale. This boiling is plasma, superheated electrically charged gas, constantly rising, cooling, and sinking. The result? Granules, giant bubbles, each as big as a continent, covering the sun's surface. These granules last only 5 to 10 minutes before being replaced, making the sun's surface a dynamic, ever-shifting landscape. The bright centers are hot plasma rising, the darker edges are cooler plasma sinking. This process, called convection, is like a cosmic engine, moving energy from the sun's interior to its surface. High-resolution images let us watch this process in stunning detail. We can even glimpse the chromosphere and corona, layers where solar flares and eruptions begin. By seeing these features so clearly, we're getting closer to understanding the engines of solar activity. The sun's surface is a dance of boiling plasma, shaping the space weather that affects us all. Let's dive deeper into solar granules, the visible signature of the sun's energy transport. Energy from nuclear fusion in the core travels outward, eventually reaching the convective zone beneath the photosphere. Here, hot plasma rises, cools at the surface, and sinks back down, creating the granular pattern we see. Each granule is the top of a convection current, a colossal engine of heat transfer. New images let scientists measure plasma flows upwards in bright centers, downwards in dark lanes at speeds of several kilometers per second. Granules form, evolve, merge, and vanish in a dynamic mosaic, all driven by the sun's relentless energy. These patterns aren't just beautiful, they're crucial to the sun's behavior. The movement of plasma generates and twists magnetic fields, the root of sunspots, flares, and solar storms. By studying granules, we get closer to understanding the mechanisms behind powerful solar eruptions. It's like studying individual cells to understand the health of an entire organism. Each granule is a clue to the sun's inner workings. The more we learn, the more we realize how interconnected every part of the sun truly is. Unlocking these secrets helps us predict and prepare for the sun's impact on Earth. How do we see these incredible details? Enter the Daniel K. Inouye Solar Telescope, or DKIST. Perched atop Haleakala in Hawaii, DKIST sits above much of Earth's atmosphere, giving it a crystal-clear view of the sun. Its 4-meter mirror, the largest of any solar telescope, collects more light and delivers higher resolution than ever before. DKIST can see features as small as 20 kilometers across, like spotting a coin from hundreds of miles away. Observing the sun is challenging. It's blindingly bright and hot. DKIST uses advanced cooling systems and adaptive optics to keep images sharp and instruments safe. Adaptive optics correct for atmospheric distortion in real time, making images nearly as sharp as those from space. But DKIST isn't just about pretty pictures, it's a scientific powerhouse. Its instruments measure magnetic fields and plasma dynamics with unprecedented precision. DeKist is opening a new window onto our star, probing mysteries that were once out of reach. This telescope marks a new era in solar physics. With DeKist, we're poised for decades of discovery about the star that sustains us all. The sun's secrets are finally within our grasp, and every new image brings us closer to understanding our place in the cosmos. Why study the sun in such detail? It's not just for beautiful images or curiosity. The sun's activity can have major impacts on Earth and our technology. Solar flares and coronal mass ejections can disrupt satellites, communications, and power grids. Our modern world depends on technology vulnerable to space weather. By understanding the sun's surface and atmosphere, we can better predict and prepare for these events. Improved forecasts mean we can protect satellites, power grids, and even astronauts. Studying the sun is essential for safeguarding our way of life. The sun is full of astonishing facts. It contains 99.86% of all the mass in our solar system, holding everything in orbit. The sun is middle-aged, about 4.6 billion years old, with enough fuel for another 5 billion years. Every second, it converts 4 million tons of matter into energy through nuclear fusion. The energy that reaches Earth powers all life and drives our climate. Light created in the sun's core takes hundreds of thousands of years to reach the surface, but only 8 minutes to reach us. The sun's life cycle will eventually see it expand into a red giant, then shrink to a white dwarf. Our star is a colossal nuclear furnace, shaping the fate of our solar system. The more we learn, the more incredible the sun becomes. Space weather can be beautiful, think auroras, but also dangerous. Powerful solar eruptions can overload power grids, damage satellites, and disrupt communications. The Carrington event of 1859 caused global telegraph failures. A similar event today would be catastrophic. Astronauts and airline passengers can face increased radiation during solar storms. That's why studying the sun is about more than science. It's about planetary security. Early warnings help protect our infrastructure and technology. Understanding the sun's magnetic dance is key to keeping our world safe. DeKist is just one part of a global effort to understand the sun. NASA's Parker Solar Probe is flying closer to the sun than any spacecraft, sampling the corona and solar wind directly. The solar orbiter from ESA and NASA will take the first direct images of the sun's poles, crucial for understanding its magnetic field. These missions work together. DeKist provides detailed surface views, Parker samples the corona, and Solar Orbiter gives a global perspective. Combining their data will build a complete model of the sun's behavior. We're entering a golden age of solar discovery. Each mission brings us closer to unlocking the sun's mysteries. The next few years promise a flood of new insights. Our understanding of the sun is being transformed. Once a mystical deity, now we see it as a complex, dynamic star, a magnetic powerhouse shaping our solar system. The Daniel K. Inouye Solar Telescope's images are more than data. They're portraits of a cosmic engine. Each discovery opens new questions. How are magnetic fields structured? What drives solar eruptions? Why is the corona so hot? Studying our sun teaches us about stars everywhere and about the conditions that make life possible. It connects us to the universe, reminding us we're part of a much larger story. As we gaze at our star with ever sharper eyes, we invest in our future and our safety. The awe we feel is a reflection of our drive to explore and understand. The sun's story is still unfolding, and with each leap in technology, we reveal more of its fiery truth. The adventure of solar discovery is just beginning.